all the word problem things that you guys see that you always go, it's so stupid. Who cares about you're buying 17 cantaloupes and 33 ice break, ice scrapers. I don't know, make it 2 fly swatters and 4 boxes of donuts at a Walmart at 6:15 in the morning. You know, it's the story of my life. You know, you never know what you have. Why wouldn't you? There's supposed to be a lot of snow on Sunday, Monday-ish, and then it's supposed to get like stupid cold Wednesday, Thursday. So there technically is no limit or threshold, if you will. It's what happens with the buses. Do the buses fire up? Today I know it was stupid cold, but not like really, really stupid cold. So yeah, it's only -25, but there wasn't much of a breeze. So if it was worse, I can see it. But anyway, so one of the first things we look at here is we're going to talk about what's called an exponential growth model. And these are really, really, really easy to work with. We have this thing called a growth model. And I want you to see that it mirrors almost identically to what we did the other day in terms of the graphing of the exponential growth. That's what you guys graphed when we did what we called a parent function for the exponential growth Tuesday, which seems so long ago. So when we did that, we had that a times b to the x, and the growth model was when b was greater than 1. Okay. Notice 1 plus something, which means that thing in the parentheses kind of playing the role of that b value. Now, what happens here is that this gets broken down into something that's very simple. When we're dealing with what are called growth models, we're talking about things that, you ever heard of appreciation or depreciation? Gain in value, lose in value, things like that. This a value is what we call our initial amount. This R value is your percent. It's your, we'll call that as a rate. It's a percent as a decimal. So if it's 17%, what's the decimal? 0.17, yeah. If it's 8%, it would be 0.08. If it's 0.2%, it would be 0.002. So remember when you're moving your decimals, I don't think it's too much in there. And then this up here is T for time. Usually with growth model and decay model, which we'll talk about here in a couple of minutes, it's usually in years. There will be another growth model that we'll talk about that deals with bank accounts, and then that could deal with what's called, you guys remember, I did this before, with compound interest, how things can compound like annually, semi-annually, things like that. Yeah. So, but hey, once you start talking about money, that's everyone's like, you perk up a little bit. So, one last little bit in here. This stuff that's inside the parentheses, this 1 plus R value, is called the growth factor. So what you'll see is it'll be written out something like this. It would be y equals 1700 1.07 to the third. When you see that your growth factor is 1.07, the rate would be 0.07, or you can say 7%. Okay, and that's what what your rate would be. And how many years would this go for? So basically, this means this is something like if you invest $1,700 at 7% for 3 years, how much money would you have at the end? That's basically what that says. You'd have money. You'd have more money because it's a growth factor, not a decay factor. Okay. Not terrible. Not yet. But look at it this way. It's Friday. Depends on the weather. Probably not. My kids are fourth and first grade. So, Actually, no. When we figured out this rule, it was about, it's like 2 minutes, 3 minutes maximum as far as shorter. First hour is actually longer because of the announcements, but then because there's no flex, everything else is about 2 to 3 minutes. So it's yes. Anyway, so here's what something like this is going to look like. The population of Winnemucca, or Winnemucca, Nevada, can be modeled by blah. So this. I don't care. So what is it will give you information where it says you have a growth model, 6191 times the quantity 1.04 to the t, where t is the number of years since 1990. This is where the understanding what that stands for comes into play. Year 0 is 1990. So if I raise and I put year 0 for my exponent, what does the thing in the parentheses become? If t is 0, it becomes 1, which means what's your initial population in 1990? There you go. That's where this comes from. Okay. So this is your starting population in 1990. What is the growth rate? 4%. Very good. The growth factor would be 1.04. See the difference there? Now, questions that they'll say here, we just answered it. What was the population in 1990? 6190. Okay. And then it says, by what percent did the population increase each year? 4%. Now, what if I asked you what was the population in 1997? Because year 0 is 90, 91, and so on and so on. You just count upwards from there. So what we would do is just throw this literally in the calculator. So is it 6191? 6191 parentheses 1.04 to the, what did I say, 7? Now, almost a full person, okay? It's not like he's missing 2 fingers. Got the snicker out of you on that one. You were like, I don't want to laugh, but that was pretty good. Go on, say it. So, I don't know. Anyway, so what would you say as far as population is concerned for something like that? Round up, yeah, because you're not going to have half a person. Modeling isn't, I mean, now that's rather discriminatory, don't you believe? You believe somebody's not a fourth full person? Well, they can be a bad person, but they're still a person. Right? Murphy just got all deep there, didn't he? I just like the idea of missing a finger. That's all I was going with. That wasn't even like saying you're like a bad person. What if he was a shop teacher? And he was called Stumpy. Was it? Didn't you say you had the shop teacher for something? You know, yar, he's a hump like a snow hill. This is where it gets more interesting. Not that it's more difficult, it's just more interesting. Because I'm getting there. Relax. Jeez. Compounding interest. This is where you start talking about banks. This is where you talk about your savings accounts. This is where you start talking about how you can put money away to save money on different accounts, what's going to pay you back the biggest bang for your buck, and things like that. Where you've got what's called, excuse me, a compounding interest formula is your overall amount is equal to this value P, which is still your initial amount, times, it's a growth factor, obviously, because it's 1 plus something. Whatever your rate is as a decimal again, n, and I'll explain what this n value is, n is the number of times it compounds. For example, if I say it compounds annually, how many times a year does it compound? Once. If I say it compounds quarterly, how many times? 4. Monthly. Semi-annually. 2. Daily. Hourly. Very good. So that's what this value of n represents. Number of times it compounds within a year. The problem itself will say that. It'll say, how much would you earn if you deposit $1,000 that compounds monthly over 10 years? Something like that. At a certain rate. Again, these aren't really, really tough, crazy things. We'll put these other one up here. So our first one was. I'm sorry, what's that? It's 1 plus the rate. The rate was the decimal. It just so happens that when you add a decimal to a 1, you get a dollar. Oh, right. Okay. This value P, again, is your initial amount. They call it your principal. It's how much money you deposit into an account. And A is your overall amount when you're done. So, for example, if you deposit $1,000 into an account at an 8% annual interest, deposit as much money you can if you get 8%. Find the balance after 1 year if the interest is compounded with a given frequency. What that means is how many times it will be compounded throughout that year. Okay. Now, remember, we're dealing with something very simple. Overall amount is your principal, 1 plus the rate divided by n. Remember, your rate will always be the percent as a decimal to the n t. Well, how much money are you initially depositing in the account? $1,000. What value does that go for? The P. Very good. So it's 1,000 times the quantity, 1 plus. Our rate was 8%, so what is that as a decimal? 0.08, okay. So we've got 3 versions of this to do. I don't want to do this after 1 year, because that's too easy. Let's do it after 10 years. Not like it's in it. It's just an extra button, basically, in your calculator. I don't know if you realize this, you kind of have to have a calculator for this. So let's just say after 10 years, or how about this? Let's make it even different. 18 years, let's say your grandparents or your parents or somebody that actually liked you when you were born decided to put $1,000 decided to put $1,000 into an account that was going to earn 8%. 18% here, I can give you everything. We'll see what would happen over time here. So annually, that means your n value is 1, and then it'd be 1 times 18. What's going to change with this idea through the other two? The n value. So what you can do with the calculator, obviously, what do we say? 1,000 parentheses 1 plus alpha y equals. Our rate was 0.08, and we're going to do it annually first, and then this was to the 1 times 18. And notice how I'm writing it into the calculator literally the exact same way I just wrote it out on paper. Because now when I hit enter, I'll know how much money I'd have after 18 years. Not bad, almost $4,000. Okay. But I want to see what was the next one it said? Quarterly. If I change that to quarterly, what's nice about using the calculator, you guys know how to overwrite stuff on it? Just overwrite your 2 values. So again, I'm just going to, instead of having to retype it, hit enter, and I'm just going to backtrack here. Quarterly means what? 4. Change that to a 4. Change that to a 4. And then hit enter. I like that account better. Right? Don't you? Wouldn't you like to go back in time and say, no, get it compounding quarterly. I want my extra $200. Or close-ish. The other one I think was daily. If it's daily, what is it going to be? 365. Now, when you overwrite with 365, you got to be a little bit careful. You might have to actually hit the insert button. And yeah, annually just means is a 1. So let's see. Your calculator is easier to do this. Oh, I can't just overwrite. Oh, that's cool. I think there's 2. We have to type in on the computer and see if it came with a red line. And then this one, I just have to change that up a little bit. Oh, it was 18. Ooh, that's even better. So, as you can see, the more often something compounds, the more money you have. Do you know why that is? What's happening is that it's calculating the interest more frequently. So if you went through a whole year, and then they calculate how much interest you earned on that account, then they add it to that account. Then they go the whole year, calculate the interest, they add it to the account, they go a whole another year, calculate the interest, and add it to the account. Whereas if you're compounding that interest more frequently, it's going to compile quicker. Okay? Because you're earning more money faster. It's that incremental amounts. This is kind of where banking, I mean, obviously, we're talking about cash here. Banks, I think they give you the two, I'll give you the 2 decimals, but then what happens to all the miniscopic or the microscopic values of money over time? What do you think happens to that? You ever seen the movie Office Space? Okay, you're probably going to have a longer weekend or a couple extra days coming up here pretty soon. Watch the movie Office Space. Can't show it to you in school. It's a rated R movie because they swear. I'm sorry. I hate to say that, but they do. But I know I'm really sorry, so I hate to recommend it, but it is really, really, really funny. But the whole scam of the thing is that they wrote a computer program to take all these little fractional amounts of pennies and dump into an account over time, and all of a sudden they have a lot of money. Like, oh, we're gonna go to prison. But it's really good. It's also 20 years old. It's yeah. Is it black and white? No. Try to light your day a little bit with something interesting.
You know what would be interesting?
You can wish in one hand and the other, see what fills up first.
Well, if you tell me to leave, I can have you go on YouTube.
Say that though. Anyway, I don't even do this. This is too easy. Decay. Gee, what do you think the difference is between growth and decay? Minus. That means if you remember, your decay. When we did exponential decay back on Tuesday, remember the b value was between 0 and 1? The reason that was happening is because you subtracted that percentage. You subtracted that rate. So all of your depreciation, where this comes into play, gets into this. Okay? Now, again, everything else, all the values here mean the same. A is your initial amount. R is still your rate as a as a decimal, and T is time in years. Okay. That's the same setup as growth. The only difference is that when you're reading a problem, you have to make a decision. Is this appreciating in value or is it depreciating in value? Pretty easy to tell. More often than not, your banking problems are growth. When they're dealing with, you ever heard of the term called a depreciable asset? What is it? Very good. Now, do all cars depreciate? It depends, right? I mean, the moment you buy a $40,000 car, you drive it off the lot, it's not worth $40,000. Okay. Depending on the car, it could be worth 35. It could be worth 23. It depends on what values things hold. Okay. Certain cars, certain styles, certain things like that hold better value than others. You guys are probably still too young to remember when the big financial crisis hit back in 07, 08-ish or so. Leading up to that point, everybody, kind of like how it is right now again, everybody was buying giant SUVs and big trucks and all that. And then all of a sudden that hit and gas went to $4 a gallon and nobody was buying them and the values of those plummeted. So when that happened, we bought a Suburban because they were cheap. So you do stuff like that. Now, certain cars hold value better. Now, I know most of you guys are at the age of, I can't cars, start thinking cars and stuff. Well, even though you're probably not going to go out there and buy yourself a brand new one, you can. It's awesome. Lord knows I couldn't. But you're looking at for something that would be something that would hold its value because you're going to want to have reliable transportation that'll last you for a few years and still be worth something to you if and when you trade it in later on. Okay? So if you're looking at smaller cars, I think our first car, one of the small cars that we had bought, my wife and I, we bought a diesel Jetta back in 05 or so. And that car then, I think we bought it brand new. It's like $22,000 with a diesel, and it got 42 miles to the gallon. We drove that car into the ground, 140,000 miles on it. The headliner was falling apart. The door panel, it was rusting up a little bit here and there. But it was after 10, 12 years of driving that thing forever, it still got 42 miles to the gallon, and it was still worth a pretty decent amount when we traded it in. Certain cars hold value longer than others. Okay? So you start looking at those things. Now, you were saying that some cars, they'll depreciate, but over time, your term appreciate. Now, I'm a car guy. I like cars and motorcycles and things with engines and go vroom and fast. And what's that? No, yeah, you couldn't tell, right? No, talk about motorcycles and cars and boats and whatever. But I was watching the Barrett Jackson auctions on the TV. They have it on the TV nowadays. It's a really cool thing. It might be a thing. What was it? The Ford GT, the new Ford GT. If you could even buy one, they're like $300,000, but people are buying them and reselling them already for millions. Ferraris, old Ferraris. If you have the money, I recommend one because it's just going to gain in value. Originally, an old Ferrari might have cost 20 grand back in the 60s, but 20 grand in the 60s is like a lot of money. But now they're worth 20 million. That's a pretty wise investment. Dumbest thing that you may think of that I'm kind of nerdy about, you may or may not know I like Pearl Jam. I've noticed. So there are certain posters. That one's a knockoff. If I had the real one, I would be hanging in my classroom. That specific poster, my wife and I took my wife to that show, surprised her with tickets for it. We actually had front row seats right behind general admission. We were about 20, 30 feet from the stage. It was awesome. But we got to the show late because we drove. It was out in Moline, and we left after school one afternoon. It was a Friday. We left right after school and got out there. I wasn't able to buy the poster. Posters were like $35. That's worth, if you have an original one, about $900. Yes, I know, it's stupid. People will pay money for stupid things. Okay, and it's certain things appreciate and depreciate, things like that. There are like shoes. People are really like Jordans. You know what I'm getting? You buy if I still had my Jordans from '92 that were if they were in decent shape, it'd be awesome. I could sell those for a few $100s. No, they're throw. I'm like, I don't want these anymore. I just threw them out. This is important stuff, right? There's cars. there's a Pearl Jam poster that looks like a Cracker Jack box. You remember the Cracker Jack box? You never had a Cracker Jack? Seriously? You've never? Buy me some peanuts and Cracker Jacks. I don't care if I'm dying. Oh. All right, we'll have them in class. Yeah. Like caramel popcorn with toffee and peanuts. Yeah, if you're allergic to peanuts, don't eat that because you'll die. But there's a poster. Yeah. There's a poster that's, I don't know, it's a little bit about this wide, about that tall. It's worth right around $1,500. It was $35 to buy. That's how fat. That's stupid things appreciate. So if you get lucky and you find something that's worth money, hold on to it. Anyway, so you buy a car for 24 grand. You'd be surprised at what things are worth in debt. Oh my God, the Beanie Baby bubble. I totally forgot about that one. Beanie Babies. Back in, that was what, 91, 92, something like that? My mom, it's like when eBay first started. She's like, oh my God, I gotta get all the Beanie Babies. She bought totes and totes and totes of these Beanie Babies. Oh my God, they're worth so much money. I'm gonna put you through. Is it the Princess Diana one? Yeah. Well, it is. I think my mom has a couple of those too. And it's like, do they still? Because I know they dropped. They sold Beanie Baby covers for the Titan covers. And you guys ever collect baseball cards? Baseball cards back in my day. Baseball cards were huge. You would buy baseball cards and you'd get this thing called the Beckett catalog. The Beckett catalog would tell you how much certain things are worth. And you'd be like, oh, I can go to the baseball card trading store and you can trade it in. You know, I've got a Michael Jordan White Sox baseball card. I've got some random ones that I've saved. You know, Connor for Christmas, he got an autographed. What's his face? Rizzo. Sorry, drew a blank. He got an autographed Rizzo baseball card for Christmas. So someday that might be worth something. I don't know. Anyway, before we run out of too much time here, you're gonna buy a car for 24 grand because never get off topic. The car depreciates at 16%. Write the model and figure out how much it's worth after 2 years. In these problems, they talk about graphing it. I am not going to have you graph any of these things. It's just, the graphing is dumb. If there's any graphing involved, we'll look at it in the calculator and I'll explain to you how we can do some intersect, how we can look for certain values over time. But I wouldn't worry about that. So you're talking about your initial amount was 24 grand. What's the rate at which it's depreciating? 16, so as a decimal, that's going to be 16%. Do you have to write 0.84 in the parentheses, or can you write 1 minus 0.16? I would always write that, because that way you don't make the dumb mistake of accidentally writing 0.96, you know what I mean? But no, you're not wrong. And then it says for T, so for 2 years, you would just put a 2 here for that. Beep, boop, beep, boop. Press buttons in the calculator, and it tells you your car is worth 18 grand. I was close. What did it equal? 16934 point what? Just one decimal? 0? Just says 0.4. Okay. Now, if you wanted to estimate what year the car is worth 12 grand, go to your table. Very good. Now, when you go to your table, what do you have to change from this thing that we just wrote down? What would you have to change? Louder. The exponent. Exactly. What we would do then, when you see this type of question, use the graph to estimate when something occurs. Change it to the x, because the exponent is the variable here. The exponent is what's going to change. The rate doesn't change. The initial amount doesn't change. It's still a decay model. You're just looking at when is the value change. So you start looking through for when you get that 12,000. So let's see. It was, back this out, 24,000 parentheses 1 minus 0.16. And it said we're looking about when is it worth about 12? I would say after 4 years. And that's how I would answer that. After about 4 years. You're not looking for
June 2nd in 1994.
what?
Very sorry. Was it offending?
That one guy from the thing? You know, on the thing that you might have seen once? Or... I can honestly say I've never seen that. I'm sure it is. Oh, remakes are always the worst. I'm trying to think if there's any good remake movies. Would you call James Bond movies remakes from the different characters? The guys who play James Bond? Do you guys even buy stereo systems anymore?
You? It's rap.
No. What do you think?
That was the thing, no rap.
So these are very straightforward. It's either growth or decay. Make sure you have these 3 generic formulas written down. That's what we're looking at. It's a matter of just throwing some stuff in the calculator. If we're here on Monday, we'll go through what's called exponential. It's the value of e. It's when you compound things continuously. We'll talk about that, and then we'll talk about the graphing of it and how that works as far as its word problems. Very, very simple. And then probably the rest of next week, we'll probably just work on a bunch of word problems. I've got, obviously what we're doing today are going to be pretty simple. I didn't want to make anything too difficult. But yes, I can make it a little bit more difficult. I can say, how much money do you have to invest at the beginning to have so much at the end over so many years? We're just working backwards to solve an equation. Again, it's not going to be anything you're not going to know how to do, bless you. But it's just going to take it that step further. But I think that it works itself out well. If we do wind up having to miss a few days at all next week, it just looks really bad. And then it's kind of this is a kind of a decent place if we have to stall. I can throw you guys an email or something. Say, hey, try this one. Your brains don't get mushed. Suck up. Yes, sir. What do you got? Oh, is that today? That's next week. The talk. When was the meeting? Yesterday? Oh, crap. I was supposed to be at that. And I had a meeting. And I went sick. I had to phone my sick kid. Oh, I was told. I know. I was supposed to be at that meeting and tell you guys about it. Did Miss Rouse realize that I wasn't there? I got to talk to her. I said, I feel bad. I told you about that.